How are you doing? Did you have enough time? Okay, what are the three conditions of continuity? Think about it like this. Oh, give me one. Limit. Function c from the left of a function equals, I don't know why those commas are there, from the right of the function equals f of x or f at c? At c. Beautiful. Left hand, right hand, and the point itself all come together to make continuity. You with me? There are three types of discontinuity. Give me one. Shout it out. Jump. That's when the left hand limit and the right hand limit don't match. What else? Removable. What's the more common everyday word that you would call that? A hole. Okay. Removable is the vocabulary you'd see on the AP test. Where's the removable discontinuity? They wouldn't call it a hole. They'd call it a removable discontinuity. That's why I don't just call it a hole. That's vocabulary you need to know. And what's the last one? Infinite. What usually is going on at an infinite discontinuity? There's some kind of asymptotic behavior, okay, where y goes infinitely long. All right, are we good there? Okay, those will gradually get in your brain, whether you want to or not. Intermediate value theorem is just a total common sense kind of idea. You will find it very easy. The hard part is the writing. You'll do a lot of writing in this class, especially for pre-response. This will be a little bit of writing. The concept is easy. The writing, how to say it well, that's the part you want to focus. First of all, intermediate value theorem is, I will often abbreviate it IVT. You can also abbreviate it IVT on the AP exam. And in college, when you say IVT, any math person will know what you're talking about. So that's not just my abbreviation, that's very common. You'll be able to use the IVT to answer or really prove kind of question after I'm done with you. Now, this is introduction to the idea. Say I gave you a function, but I only showed you 2 points on the function. So there's a graph here that's missing, and I'm only telling you that it has the points 4, 0, or 0, 4, excuse me, and 4, 1. In between, I don't really know what's going on. Must there be an x between 0 and 4 where y equals 3? If in the missing space, did it have to go through 3 or y is 3? Does there have to be a place where y is 3? Yes or no? How many say yes? Raise your hand. How many say no, not necessarily? Raise your hand. Okay, the answer, too bad, is no, not necessarily. And that's because you're assuming the graph goes from there to there, and that is not necessarily the case. Because the graph could do this. And now, maybe it has an asymptote there. That's one possibility. It also, say the graph does this. It says, whoop, and there's a big old hole at y equals 3, and does y equal 3 ever? Not so much. And so, it's not necessarily the case that it must pass through 3. If the function is not, what's going on? What's the problem here that's causing it to not pass through 3? If there's what? I heard somebody say something. Say again? Removable but we also said vertical asymptote, so wouldn't you agree that any discontinuity is a problem? If the function is discontinuous, then not necessarily. Okay? But if the function is continuous, then yes, y must equal 3. Okay? If, in order, the layman's definition of continuity is to be able to draw without picking up your pencil. Is there any way I could draw from there to there without picking up my pencil, and it not being continuous and not passing through 3, if I continuously go from one to the other, it must be 3 at some point. Do you agree? So as long as continuity is there, it has to pass through 3. Does it have to pass through 2? Y equal 2. I'm saying y equal 2. Must it pass through y equal 2? Yes. Must it pass through 3.8? Yes. Must it pass through 1.2? Yeah. Does it have to pass through only once, or could it pass through multiple times? It could pass through multiple times, but it must pass through at least once. It must pass through all these numbers in here. Must it pass through y equal 5? No, not necessarily, because why? Just shout it out. It doesn't have to pass through 5 because what? Okay, straight line and 5, so why not 5? How come 3 was a yes, but not 5? Because what? Negatives. Okay, so what about positive slope? Don't worry about the slope. You don't know about slope. What about this? This has some positive slope and negative slope. It's because 3 has to be passed through because 3 is between. Thank you. That's the word I was looking for. Between. 3 is between, but 5 isn't. So 5 is not between the y values y equal 4 and y equal 1. So not necessarily. So the IVT really has 2 components to it. If the thing is continuous and the number they ask about is between, it has to pass through that number. It must. Okay? The intermediate value theorem then says something like, this is a layman's idea, that is, if a function is continuous and goes from one point of an interval to another, it must pass through all values in between. That tends to work better for people than the actual book definition of the intermediate value theorem, which is if f of x is continuous on a closed interval, then for any y value m between the 2 endpoints, there must be an x value that makes that y value. You can see why that is a little intimidating, and I'll start with that. All right? So don't worry about the formal definition. We're going to use kind of just the concept. As I told you, the concept isn't too hard to understand. It's got to pass through all the y values in between, and it's continuous. The writing of it is a little more difficult. But I got to tell you, last year they did very well with this, and they got it really quick. So these are the 3 things I want you to consider. This is the kind of problem you're going to see. It's not so much a calculation, but a justification or reasoning. Must there be a place where sine equals 0.2 in that interval? Well, it doesn't ask you to solve it, okay? It doesn't say, all right, find the place where sine equals 0.2. That's not the question. It didn't say, find where sine is 0.2. That's not the question. It said, must there be a place? And justify. Now, start with, is the function continuous? When you see must there be a place where it passes through this, think IVT. The first condition is continuity. So start by saying sine, the sine curve. You're going to have to think about that in your brain. Is that a continuous curve? Yeah. Okay, so say that. Sine is continuous. The first condition is met. The second condition we talked about is betweenness, all right? They ask about the sine equal 0.2. Well, let's see what it is at the start and the end of the region. Yes? Oh, you're stretching. Sorry. Okay, let's see what it is at the start and the end point. So find the endpoints. Sine of 0. At the starting point in the region, we have sine at 0. What's sine at 0? Sine of 0. 0. What's the sine of the other endpoint, pi over 2? 1. Okay? Now, if sine at the start of the region starts at 0 and later ends at 1, what must it pass through in between? It's got to go through 0.2. It can't go from 0 to 1 without passing through 0.2. Do you agree? So we're going to, therefore, make the conclusion. Now, this is the part where you're going to do the writing. You're going to say, Sine is continuous. I guess I didn't need to say that twice, but I'm going to say it. And point 2 is between 0 and 1. Now, we're not going to say that. You can say that in words, but symbols are created to cut out the work. So we say that in symbols by saying point 2 is between 0 and 1. Sine is continuous, and point 2 is between 0 and 1. So by IVT, we're basically citing the theorem, or why you say this is happening. There's a theorem that says, by IVT, there must be a place is an x. Now this is where you kind of restate the question. Sine is continuous, and the betweenness inequality is done. So by IVT, there must be a, and the question was, there must be an x in 0 to pi over 2, where what happens? Sine of x equals 0.2. Okay? I know students don't like writing much, especially this is every time when this is math class. Yeah, you do write a lot in here. Okay, so get used to it. Oops, not bad. Where does this go? Yeah, that works. Let's do one more together, then I'm going to have you do one or two on your own. All right? Given select values, now you're going to see table problems all the time in this class. You're expected to know calculus analytically, which is kind of what we did there. Numerically, think table of number values, graphically and verbally. All right? This is a numerical calculus problem. Given select values of a continuous function h of x, they give you as continuous, below, must there be an r? They're saying, must there be a place, which tells me, oh, this is one of those IVT questions, where r is between 2 and 5, such that h of r equals 0. Now, when you see h is the same as the function is the same as y. So I'm trying to find, or say, does there have to be a place where y is 0? Between x of 2 and x of 5? Now, here's r of 2, and here's r of 5. What do the y values go from and to? -7 to 11. So in going from -7 to 11 continuously, must you pass through 0? Yeah, so it feels like this is an IVT working kind of case, right? So let's, now these two pieces of evidence, they don't need to be gathered here because the first one is being given. I don't need to write that twice. This one is given in the table. I don't also need to write that. All I need to do here is the conclusion. And so let's talk the conclusion. Here's the basic template, whatever, for the statement, the function. Now, the function is specific to the problem. What's the function here? What's the name of the function? H of r, okay? H of r is continuous. You don't have to justify why you say that. It's given to you, okay? H of r is continuous, and now the betweenness. Continuous and betweenness. Give me the betweenness inequality. The one they asked about is between what 2 points? What's the one they asked about? Is there a place where h is? 0. 0 is between the two endpoints at 2 and 5, which are -7 and 11. H is continuous, and that point you're asking about 0 is between where it's at the endpoints. And so, by IVT, basically just rephrase the question. There is an x value, which they actually asked you to call it an r value. There is an r in what interval? Look back at this problem. There is an r in 2 to 5 where h of r must equal or just equals 0. That's the idea. Yes.
Is there like an issue that our homework or our class stuff has X and each of X in the table? Does that like affect it?
Yours has,
X
oh,
and
yours, you, oh. So sometimes, gosh, okay. Yours has X's. Okay. Sorry, that usually is the case where I did this last year and I felt like, oh, students got confused by R, so I changed it to X for you, but then I forgot to change my presentation. So, sorry, just, you're using X's, sorry. Wish you would have told me that before. Why didn't you tell me that earlier? Okay, so my work has all these R's and O. Are you saying here?
No,
Yours is X everywhere.
it's X, but then it has like the questions.
R's.
So I'm not in the H of R.
No, let's change, sorry. Would you change every X you see to an R? That's just my stupidity, I'm sorry. Gosh, as if this wasn't hard enough. I got mistakes on top of this. I'm so sorry. You with me? Change every X you see to an R. So it's all consistently R, 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 R. You with me? All right. You try. At time equal 2 seconds, the velocity of the car was negative 2 meters per second. At time equal 10 seconds, the velocity of the car was 10 meters per second. Was the car ever at rest? Try this on your own. Talk it over with your friends. I'll be walking around, and we'll go over it in a minute. Okay?
It's going forward. I was just
Actually, you're right. Backwards is a better word. Takes a few seconds to write that up. Call it writing. I'll give you a minute, and we'll go over it. I'll walk around with those students. I mean, say hey to that. Okay. All right, let's go over it. Make corrections as necessary. If you have something slightly different, ask and say, "Is this okay?" That's fine too. It doesn't have to be, verbatim what I have, but fairly close. What do you say? First of all, do you need to do the first two gather evidence steps, or is this one like everything's given to you? Everything's pretty much given. I'm going to go right to the conclusion. So first of all, what's the function we're dealing with here? What function are you doing? Okay, let's go back here. What two things are varying in this problem? There are two variables. Time and velocity, okay? Which one's the function? Velocity is a function of time. Different velocities at different times. Your velocity depends on what time you ask, how fast you're going, right? So when I say the function, in this case the function is velocity. Is velocity continuous? Yeah, this comes to us on your physics knowledge. Velocity is continuous. You can't go from moving left to moving right without all the velocities in between. So velocity is continuous. And what about the betweenness? But if so I guess we should have gone back and decided, what does this mean? Rest, what does that imply about velocity? Velocity is zero. So really the question reads, must there be a time when velocity is zero? Now let's talk betweenness now that we have that established. Is zero between the two given velocities? Yeah. So velocity is continuous, and velocity of zero is between negative 2 and 10. So there must be a time in what time frame between when? Or, yeah, so you could say between time equal 2 and time equal 10, or you could say something like a time in 2 to 10. Either one of those would work. But there must be a time between time 2 and time 10 seconds when, what? When it's at rest, when velocity is, I'm going to actually make sure the person reading this knows that I know the connection between velocity is zero and the car is at rest. So I'm going to throw that in parenthetically just to really make note. You with me? Did that go in? Okay. So that's that. Do you want to try one more off the homework, or should we move on to last night's homework? You want to try one more? Okay. Why don't you go to number, the first few problems are intermediate value. Try, the one that might give you a little bit of a pickle is 2. Try 2 on tonight's homework. Talk it over, and give it a go, and we'll talk it over. This is gradually gonna, throw a few wrinkles, but they draw from skills in your background, so you'll be fine. I'll be walking around in a minute. Where's that document? Yes. C's and X is it? C. Oh no, C is good. Sorry. That's okay, actually. So maybe that R was okay. I just. Oh, I'm sorry. Okay, so actually, that whole time my work was fine. I thought I had a typo in there. I'll explain in a minute. Just proceed. We can work together. Ask Dr. Vance today in this parent class if you need help. That's fine too. I'll be walking around. The hardest part is probably getting those endpoint values. Okay? Which you should ask if you get those endpoint values. Let me know if you have questions. So, you need the endpoints at 35. So, K at 3 is in G of F. So, I would write K of 3 equals G of F of 3. You know it's continuity is given, so you don't need to sweat that, but you should start by finding the endpoints. K at 3 is G of F at 3. Now you bust out those algebra skills, and that's where the table comes in. What is G of F of 3? Work inside out. G of F of 3, work inside out. Well, a lot of people are working on it. I say this right now. We need to understand. People from SDAN's class, listen to me, okay? I know this is review for many of you. You can do this in your sleep. And you will not insult me or hurt my feelings in any way if you're working on the homework while the other people are still working. That's fine with me. Go for it. Okay, use your time wisely. Yes, please. I assume. Now that wasn't okay, right now, without that, was a good job. Okay, awesome. How we doing, peeps? Peoples? Okay, cool. I don't know if I can help.
So you start off, how you go step by step.
Students not ready? Okay.
Yeah, it does start off the first one. You just start with it. You know how to find that and rewrite it. And what you're doing here. Now it's a key. New one. I don't know if this was confusing
All right, are you ready, my friends? Okay, I need to establish continuity. Continuity is given. Now, I helped you here in that saying F and G are continuous, so K must be. That wasn't in the actual first AP problem. It's kind of on you to gradually understand that if two continuous functions come together, they make a continuous function. All right? So K is continuous, check. I'll talk about the CX issue now that I have clear my mind. Don't worry about the CX for a second. Right now, do you agree we need the endpoints? K at 3 means G of F of 3. to evaluate g of f of 3, I first need f of 3, which is 3, and g of 3 is 4. Now, I showed a lot of work here. You do not have to show that work. If you just said k of 3 is 4, that's fine. I just wanted you to see where it came from. You with me? Do you agree that k of 3 is 4?
Yes.
Okay, cool. What did you get for k of 5? Negative 1. Do we all agree there? Does anybody not see where that came from? Okay. K then, which is like y values, passed from 4 down to negative 1. So think of it like here, whatever k looks like, it passed continuously from 4 down to negative 1. So must it have passed through 0? Now let's talk about that c thing. This is the part that, remember on the one we just did where there was all this rx confusion? You with me? Here's the same cx confusion. Understand here, x is the whole function. X is all variables. When they talk c, they're saying, does there have to be some specific place, c, in here where c has to, where the y has to be 0. So when they say c, they're referring to more like, is there some specific place in this x region where there's a 0? And so don't get hung up on that. C is just a specific. Does there have to be such a place where k at that x value or y equals 0? Is betweenness satisfied? Yes. Okay, so let's say a conclusion. Get me started here. What did you say? Start reading your answer. K of x is continuous. That's the first part. And 4 came first. Is this true? Say somebody wrote this. Is that good math? No, 4 is not less than 0. That's ridiculous. So you could either write 4 is greater than 0, which is greater than negative 1, or negative 1 is 0 is less than 0 is less than 4. Do you agree both mean 0 is between?
Yes.
So both are fine. Okay? And, oh sorry, k is continuous. The betweenness is satisfied. So, by IVT, what else? There is a C where? In 3 to 5, oops, in 3 to 5, or between 3 and 5, you could say it in words, between 3 and 5. You could say there's a C where C is, I mean, you could actually basically just regurgitate that, such that, or where, what? K at that point equals 0. Okay. That's really as yuck as they're going to get. Hi. You're here. Somebody tell this young lady what IDT means in 5 seconds. Oh, wow. I'm surprised you didn't give it a go. I think that's good job. Thank you. I'll get you caught up. All right. Would you got last night's homework, which good question. It should be graphics. Thank you. Now that's excellent. I mean, that's paying attention to details, and that's awesome. All right. Some of this, I had examples for you in class, but some definitely were not like the examples I did. So I'm going to, for the benefit of the students that just killed this, I'm going to throw out the answers so that if you killed this, you can go on with tonight's homework. But then we're going to go over, I'm going to go back over it a little quicker, right? So x equals 0 is a removable discontinuity, and x equal negative 1/2 is an infinite discontinuity. We'll go over the work later. If you want to ask about that, just start or something. Number 2 had none. Number 3, x equals 1 is a removable. X equals 0 and negative 1. Maybe I think I had one of these missing from your work this morning. I don't? Oh, you had both of them? Okay, cool. X equals 0 and x equal negative 1 are infinite. I spelled infinite wrong. That's really bad for a calculus teacher. Okay. And 4 had none. All right. 5. K equals 5. 5, 6K equals 4/3. By the way, especially those of you who feel really confident, if you disagree, let me know, because I do make lots of mistakes, you'll see. 7, sketch a graph with a removable discontinuity where f at c is defined. Removable means what kind of graph attribute? Hole. F at c, so here there is a removable, so there's a hole at c. When they say f at c is defined, that means there is actually a place where there is a dot, it's just got a hole there, so that would mean that f at c is defined, it's just got a discontinuity there. This would mean you've got a removable discontinuity and f at c is not defined, so which is to say there is no point at c anywhere. I think this answer was C. The next one is B. Backside. This one was a humdinger, baby. A is pi, B is 3 pi over 4. That one was hard. This one, I would be giddy with joy if anybody got this, including Miss Cans, because I doubt you have a problem like this. But this one's tough. This, first of all, I'll explain a case where someone might want to make less money. First of all, the idea that your tax rate would increase as you make more money, that's called the progressive tax. As you progress, you get taxed more. I'm not going to get into the ethics of that. I'll let your econ teachers talk about that. But for now, say the structure in this country that was filled with people that don't know anything about math said you get a 5% tax rate if you make less than $30,000, but the minute you make more than $30,000, you're going to pay a 10% tax rate. What kind of two cases would make that seem really weird, where it would actually be better to make less money? What?
Tax.
Okay, because of the taxes. Now let's get specific. Say a person made $29,000. Starts with $29,000 before tax. Okay? How much tax would they pay? I hope you could do that mentally. What's 10% of 29,000? 2,900. What's half of that for 5%? That's the math, people here. What's 10% of 29,000? 2,900. What's half of 2,900? You get 5%? 1,450. Okay, so your tax is 1,450. Your after-tax income is 29,000 minus 1,450. So what is that? You guys are terrible. 27,550. You with me? Okay. Now, the minute you trip over 30,000, you're going to start to pay a higher tax rate. So maybe you make 30,000 before tax. It seems like that person is better off, yeah? I mean, wouldn't you rather make $30,000 than $29,000? Heck yeah, the extra $1,000. And yet, if you're math smart, you'd say, no, I don't want that 30,000. Okay? Because your tax, what's your tax if you make 30,000? 10% of your income, your tax is, what's 10? God, please tell me you can do that mentally. 10% of 30,000, 3,000. What's your after-tax income then? 27,000. So the person that started by making 30,000 after taxes actually makes less than the person that made 29,000. What's the, if you're around that case, what's the best you can make? What would you want to make? $29,999.99. That would be under the threshold. Now, do you agree that's a defective tax structure? That's anti-capitalism to say, I want to make less. That's not the capitalist way. The capitalist way is, man, I'm greedy like a monkey. Okay? So this tax structure stinks. So you, as the new Minister of Finance, is going to come in and change the tax structure.
The problem with this, whether you know it or not, is that the taxes as a function of income are discontinuous. The taxes go from, so the person that makes 0, how much tax do they pay? 0. Up to the person that makes $29,999, that person's tax approaches 5% of 30,000, which is $1,500, but not inclusive. But the minute you make 30,000, your tax immediately goes up to 10%, and that is, as a number, is what? 3,000. Okay, and then your tax goes up from there. Tell me about the steepness of these lines. This represents 5% of your income. This up here will be 10% of your income. So what would that line look like relative to the first? Steep, it'll be steeper, your taxes. All right, now this is the problem. We need this tax structure to smoothly transition from one tax bracket to the other. Okay, this is an application of continuity. It's not just blah, 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 blah. There's actual use to this. We need it to be continuous. We're going to say we're going to keep the 5% tax structure for the poorer people, all right? So the variables here are income and tax depends on income, so tax is a function of income. That we're going to keep. We need to change the 10% structure so we get continuity. Now, I want to keep the 10%. Let's stick it to those rich people, all right? But I need this to move down a little so they meet. So what kind of basic function do I want this to be? Tell me something you do know about what that wants to be. If I'm going to keep 10%, then what do I know so far? 0.1 of what? 10% of what? Income, okay? Now that achieves the slope, but how do I cause it to shift down? Think linear attributes here, okay? What the slope causes it to have this shape, but the where it is determined by what? Well, the where it is determined by what part of the linear equation? Where it crosses the y-axis or the y-intercept, right? Are you with me? I feel like I'm not. I'm getting a lot of. I need to figure out something to add or subtract to shift the whole line to get continuity. Are you with me? All right. Now the question is, what does that have to be to make that shift happen? Well, think limits. Don't I want the left hand and the right hand to be the same? So the limit as what approaches what? What are the variables here? There's no x here. As I approaches 30,000 is the handoff point. From below, what's the rule for that region? 0.05 I needs to equal what the tax approaches from the right, which is the limit as I approaches 30,000 from the right or above. And what's that function? 0.1 income plus B. Now, this first tax bracket, as we approach 30,000, what do those taxes approach? What does the tax start to leave off at for the lower tax bracket? Direct substitution. At 30,000, what's 0.05 of 30,000? 1,500. Okay. That needs to equal this guy. Now, this, again, direct substitution. That 30,000, does it go in for I or B? I. If you put in a 30,000 in for I, what's 10% of 30,000? Hello? 3,000 plus B, we don't know. Well, what does B have to be?
Good morning, Devil Jaguars. Please rise for the
June
pledge of allegiance.
15th,
Ready, begin. I pledge allegiance
to the flag of the United States of America, and
to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. Please.
So your answer to that
All students,
is
during your lunchtime
point
break,
one
enjoy your full lunch break.
I
Don't
minus
let up 10 minutes
1500.
before the bell dismisses you from passing period. Please make sure to pick up after yourself and help your friends when they forget to clean up. Students are to stay in the designated eating areas and not wander the halls during lunch.
Today for 7 hours, students will report to their 10th hour class.
8th graders will be taking their needs assessment survey today in the cafeteria during 7th hour. 8th graders report to your 5th period class. You will call for students with the last name beginning A through K at about 1:55 and L through Z at about 2:15.
Here's the school hack brought to you by Gabe Set Process. Score for guac. If you've got guacamole on your mind, order a meatless dish and the guac is free. 5 days to go.
Let's see, forward sign.
Directory cover contest. It's that time to start designing the Princess directory and we need your help. Take up a submission form for Miss Howler or Miss Lawrence. Your form and artwork are due by September 4th at 7:50 a.m. to the office. The winner will receive $50 in addition to having their artwork on the cover of the year's directory.
Boys who want to participate in boys mentoring need to get their enrollment forms counseling right away and turn it in by Monday. Even if you were in boys mentoring last year, you will need to turn it in.
If you're interested in working on the stage crew for our town, there will be a brief 10 to 15 minute meeting this Friday after school at 2:35 in Mr. Murphy's room.
Make a Picture Day is this Friday, August 24th, for all students who do not have pictures taken on registration day. Pick up forms in the main office.
Prayer and Lunch for Students, or PALS, is a study prayer group that meets in the conference room of the counseling office during lunch on Wednesdays. We'd love to meet new people, so if interested, please come in and check us out.
Have you bugged your parents enough to get them to sign you up for the Dental Dash this Saturday? If not, you need to. Time's running out.
Just do that.
Pick up Interact applications in Miss McSammon's room. The first meeting is September 7th in the library.
Air Force Academy welcomes those who are interested in learning about Academy Life. The application process is meeting with 10 recent graduates and Colorado congressional staff. The information includes Air Force, Air Army, Naval, and Coast Guard Academy on Saturday, August 25th. If you're interested, stop by your phone.
Attention all Jacks. Tomorrow we will have a dash blast from the past. So if you are any old dasher, you will get candy as you enter the cafeteria at lunchtime.
Senior high students. Seniors, please return your senior yearbook submission forms to Mr. Jacobs for by September 7th. Pictures will be in Mr. Jacobs' room. Also, don't forget that senior photos and baby pictures are due September 7th. Instructions are on the website. Email yearbook.jax@gmail.com for any questions.
Junior high students. Attention junior high. Interested in running cross country with your friends?
Hey, Chuck,
The
the end of that, there's
informational
another
meeting today after school in Miss Ford's classroom. You will get information about practices and forms that need to be filled out by a parent. If you can't make the meeting, see Miss Ford for details. Come run with us. It's going to be a blast. Thanks, Jack. Have a nice day.
Okay. Okay, so here's the deal. We're not gonna get to questions to this, so I want you to hold on to this until tomorrow. We'll do questions tomorrow, right? If you didn't finish yet, then you gotta retrieve. We'll go with questions on it tomorrow. At the very least, you should know if you're on the right track or not. So we'll get that one. Okay, so tomorrow we'll do 2 sets of questions. This one and the IBT next semester, all right? All right.
I think physics too.